Okie dokie. So today we're going to be looking at efficiency. So we all already know that energy can be transferred from one form to another. So here it's electrical to heat, but sometimes there'll also be some wasted energy that we don't actually need, but it still comes off. So for example, with a kettle, um, we want the heat, so we want the electrical energy to go to heat, but we might have some wasted sound energy, we might have wasted light energy, and so the more efficient the kettle, the less sound and less light it gives off. So that's why we know that most devices aren't 100% efficient. So let's look at what efficiency is and see how we can calculate it. How we can calculate it, and in both in terms of energy and also in terms of power. Okay, so let's consider a lamp. Its input energy is going to be electrical, while its output energy will have some light and heat. So these will be some of the wasted. So heat, for example, would be a wasted energy, whereas light is a useful energy. Non-useful energy outputs are heat. Useful ones are, for example, light. Can also look at the efficiency, so that's a proportion of energy supplied that's transferred into a useful energy output. So so energy is transferred into light, and so you'll need to be able to calculate efficiency in your exams, both as a percentage and a decimal. So the formula for efficiency is the useful energy output over the total energy input. So useful power or the useful power output over the total power output. Let's have a look at this example. So this older bulb has 45 joules of light energy, and this is modern bulb, and it gives off 225 joules of light energy from the 300 joules that it receives. So we supply 300 joules into each. The older bulb, it is only it only gives us 45 joules of energy, and the newer bulb gives us 225 joules of energy. Now, how many times more efficient is the LED bulb compared to the lamp? So we know that the total useful output, because 45 joules is light, over the total input, which is 300 joules, 0.15, and that's 15%. And here we do the same thing. So we do 225 joules over 300 joules, which is 0.75, which is 75%. And if we want to check how many times more efficient, we can just do 75 divided by 15, which is 5. So it's 5 times more efficient. Now, a very common mistake here would be to get it the other way around. So we can't have a value bigger than 1 in a percentage or decimal. So that's one way we can check that. Now, let's have a go at this example. So a microwave is 70% efficient and has a total power output of 800 watts. Calculate the useful power output. So the useful power output over the total power output is the efficiency. So if we want the useful power output, we need to do efficiency times total power input. So let's put 70% as a decimal, so divide it by 100. That is 0.7. And then we're going to do 0.7 times by 800. Okay, which gives us 560 watts. So here we had to rearrange the equation. So no device is 100% efficient. The wasted energy for a microwave might be thermal energy, whereas the function is to produce heat. Most often it's thermal energy, whereas for a microwave, that is the wasted that's a useful energy, but a lot of the times wasted energy is in the form of thermal energy. Whereas in radiators, wasted energy could be the sound energy. It could also be if your radiator lights up with like a switch on it, lights up. But a lot of the time, the wasted energy is the thermal energy. Not in these two examples, but a lot of the time. So we'll stop there with this topic, and I'll see you on the next one.